Welcome to a video on related rates. So one thing we're going to look at is related rates in the chain rule, and on your reference sheet it states that if y equals the function g of u, where u is f of x, so the function of x, then we can say that dy dx is equal to dy du times du dx. You will note that, like fractions, if we were to cancel the denominator with the numerator, so the du's, you would get dy dx. That's a good way to remember how to use each of the formulas. Some rates that we can refer to, or rates always refer to respect to time. So an example might be at what rate is the radius increasing, so that'd be dr dt, so the radius increasing, or the radius is changing with respect to time, or the volume decreasing, so dv dt, so volume with respect to time. Here are some formulas and their derivatives. So some of these are on your formula sheet, but just in case, just a reminder of each of them. So we have the sphere, its volume, and the derivative with respect to r, so dv dr, the area or a surface area, and the derivative dA dr. Same for the cylinder, but note with the cylinder and the cone that we could differentiate with respect to r, or we could differentiate with respect to h, and I've given both of those in the derivative section, so just be aware of those. So how do we use the formulas? So our first one was that chain rule that was on the reference sheet, but you could have finding the dv dt, so the change in the velocity with respect to time. So that would equal to dv dr, so that would be the volume with respect to the radius, times dr dt, which would be the radius with respect to time. And you'll notice on the right hand side the dr's cancel to get you dv dt anyway. We know that obviously if we are talking about a sphere, dv dr is 4 pi r squared, and if it's the cylinder, it's 2 pi r h times dr dt respectively. So from a past HSC, distance A is inversely proportional to distance B, and we're given that A equals 9 over B, and the two distances vary with respect to time. We're told that distance B is increasing at a rate of 0.2 meters per second. Notice that that is distance over time, meters per second. So that is our dB dt, so it's distance over time for B. And we want to find dA dt, so distance over time for A, when A is 12. So let's start with the A equals 9 over B. So if we rearrange or rewrite the right hand side with a negative indice and then differentiate, we get dA dB. So the two things that we do have is dA dB now, and dB dt we were given. So if we write out our formula, dA dt is equal to dA dB times dB dt. So once again, notice on the right hand side the dB's would actually cancel. So that's a good way to remember. And you get minus 9b to the minus 2 times that 0.2. So that's just substituting in from the formulas that were given. We want to now find dA dt given the value of b, but we've got to find b given that we got A equals 12. So we can find B by just substituting 12 back into the original formula where the A was, and that gives us B equals 9/12, 3/4, or 0.75. Sub that in and you get dA dt is minus 3.2 meters per second. So that means that A is decreasing at a rate of 3.2 meters per second. Here's the second one. We've got a conical drinking cup, so basically a cone. Height 12 centimetres, radius of 4 centimetres, and the cup's being filled at a rate of 3 centimetres cubed per second. Notice that that's 3 centimetres, so centimetres cubed is volume, per second is time, so that's our dV dt. So we start to recognise some of the formulas that are given to us. we're going to show that r equals a third h and the rate at which the height is increasing. So rate of height, so we're going to find h to t. So first one, so similar triangles, or noticing that the two cones are in proportion. So that means their sides are in ratio. So the r over the h is equal to, from the smaller cone, is equal to the 4 over the 12 from the larger cone. And that gets you r equals a third h, the first one. So that's a typical 1 mark question. Find the rate at which the height is increasing. So we know that the formula for the volume of a cone is a third pi r squared h. We could use our differentiation, but we know that r equals a third h. So we're going to sub that in, and that gets us our volume is at 1/27 pi h cubed. Differentiating that, so you power down the front, lower your power by 1. So dv dh is pi h squared on 9, and dv dt, from, as I mentioned before, is 3. So if I want to find h to t, which is what the question's asking me, I'll need dv dt times h dv. Notice that the dv's cancel this time and gives us h to t. Now, we actually had in our formula, we worked out that dv to h was pi h squared on 9, and we want h to v. So therefore, we're just going to flip that so that we actually can enter it into our new formula. So h to t is 3 lots of 9 over pi h squared. The question says when the height of the water is 9, so you sub the 9 in, and you get h to t is 1 over 3 pi centimetres per second. Thank you.